All right, welcome everyone. Today at CITP, we are delighted to have Professor Elie Zeid. Elie is a professor at the Civil and Environmental Engineering Department here at Princeton, and he's also served as the director for Princeton's very exciting Metropolis initiative, where he thought about urban technologies that could help make our cities more sustainable, more equitable, as well as more resilient. Elie is also an associated faculty at our Andlinger Center for Energy and the Environment, as well as an associated faculty at the Mechanical and Aerospace Engineering Department. And today we're delighted to have Elie talk to us about an equitable technological future for cities. Let's welcome Elie.
Thanks, Pratik, for the introduction and for inviting me to give this talk. Thank you all for coming. So today my talk is less about my own research and more about all the reflections I had to make about basically how to ensure that as we deploy technology in cities, we do so in an equitable way. That's kind of part of my role as the ex-director of the Metropolis project of the School of Engineering. So in general, yesterday I always like nice backgrounds. I was Googling to find a nice background, and all the pictures when you put smart cities or future cities, you get these like very utopian images of green cities with nice buildings and everything looks great in these images. So how can we get there really how can we get to these future cities? So why cities? Why are we interested in cities? You might know that basically in terms of population growth, the population of rural areas in the world is stable or decreasing, and all the growth in the world population is happening in cities. So by 2050, about 68% of the world population will be living in cities. And when you just think about problems of population growth, of climate change, aging infrastructure and how you replace it, how do you have basically resilient cities or resilient infrastructure from natural or unnatural disasters, and how you basically reduce your resource needs for humanity. A lot of these problems are going to be problems that are happening in cities, and how we design and build cities is going to a large extent dictate how we interact with the planet, both in terms of our impact on the planet and vice versa. And when we think about this problem, obviously, the rapid technological transformation is going to have a central role. It's going to have a central role in basically affecting all of these other challenges and in changing cities themselves. So basically, the urban future is the one that will shape the mitigation and vulnerability and adaptation to all these changes, risks, and shocks. Now, why is technological change so important? It's the central theme of this topic. Well, cities and technology go a long, long way, and technology is central to how cities look and function. For example, if you look at the first settlements that were developed thousands of years ago, they would not be possible without agricultural technology. It's agricultural technology that allowed us to grow the extra food that basically you need to sustain an urban population that is doing other things than hunt and gather. And then basically the cities for millennia stayed like they look in this picture, low rises and basically very compact, until we developed building and elevator technology. Building and elevator technology allowed cities to grow vertically significantly, and basically sustain a much larger population. And then basically the transportation shift that started, this started about maybe 1900 or so. And this, the transportation shift started in the 1950s mainly with public transit actually earlier in 1900, but the car about 1950 became a common commodity. And that reversed the trend of densifying and cities that go vertically upward. This basically spread cities back, and they basically caused a lot of the sprawl that we see today. So you see that technology throughout history has shaped how cities look like and how they function. In fact, cities are pieces of technology. So it's very easy to think of cities as basically system of technological systems. You need energy systems, water systems, security systems, health systems, and so on to support all this dense population, to bring resources out and to take outputs out. But in this way, it's cities are not as simple as designing an iPhone, right? Because an iPhone, you basically have very controlled environment under which it works. It interacts with one user, you can control that interaction. This is a little bit different from designing, again, an iPhone or maybe something like an HVAC system in a building, because these engineered systems at the city scale are interacting a lot with socio-economic and political frameworks and systems and legacies that are going to be very important. They also need the earth systems around them to provide them with all the inputs of water, energy, and so on. And obviously, earth system and social political systems interact. So when you are trying to design cities, you really have to keep in mind or keep central to your focus all the social, economic, and political and earth systems that your city is depending on. That basically makes urban technology more challenging to design and to deploy than a lot of other pieces of technology. But that also brings up the question of what do we want these smart cities to do? I mean, what is the purpose of technology? Paraphrasing from Carlo Ratti, a professor at MIT, technology may be the solution, but what is the problem that we are trying to solve when we say we want to develop or build smart cities? So you have to remember that basically technology is a derived demand. I don't have a computer to have a computer. I need a computer to communicate, to work, and so on. I don't have a cell phone just to own it. I do it to, again, communicate or navigate. So basically, what is the end to which technology is the means? So again, what are the problems that technology is trying to solve, or what would the solution look like? And there's two versions of this. There's a techno-utopian take on smart cities, if you want. Let's say basically, well, technology is so great that it will basically be able to solve any problem that cities actually will face. However, this is obviously not very simple. So you can make these nice pictures again. But if you look at the city, you have there's no low-income housing in the city. It all looks like houses for extremely rich people. And of course, technology alone would not solve the income disparity problem in cities. So again, this techno-utopian picture is a little bit maybe too optimistic. And there's a techno-dystopian end of this spectrum, if you want, that basically asserts that technology is going to mainly be a negative or a problem for cities in terms of privacy, in terms of the end of the human species and the rise of the machine and so on. So you again can get this very dystopian picture of what technology will impact, how technology will impact the city. And so we're probably somewhere in between. And I would hope that we actually have a chance to impact that outcome. So if you want to understand how basically technology impacts systems and societies, you have to think about the agents or the enablers of technology, and think about how you can work at all levels to basically push your technological system of your cities more towards the utopian than the dystopian version. So, for example, in thinking about technologies for future cities, you can think first about the developers of the technology. These are the scientists or researchers who are advancing basic and applied sciences to engineer new technologies that could be, algorithms and sensors, but also structures, cyber physical system, materials, and so on. So in this case, to give you an example, somebody would develop a new sensor or a new type of material for buildings. And then there's the users, and the users, I'm not talking about the end users, but the users in this kind of tech enablers picture. This would be, again, the researchers or engineers or scientists who are advancing the basic and applied knowledge to develop the building blocks of the individual systems of the metropolis. Let me give you an example. So somebody develops a sensor or a material, and the user, let's say me, I would be the early adopter of this technology. I would use this sensor to understand the water cycle in cities, or I would use this material to put on a building and basically try to keep the building cool. So I'm the one who takes this technology and tries to understand how it impacts an individual system in the city. But these systems interact. So then you get to the integrators. The integrators, you can think of them as the people who will investigate how the impact of specific technology or designs are going to propagate through the complex urban systems, and what is the final impact on the city. For example, let's say we're talking about a new material that keeps cities cool, you deploy it everywhere, and the question is, how do you legislate for penetration rate, market penetration of this material to be high? Who pays for it for low-income housing? What is its impact on the energy systems at the city scale, and so on? So they are basically the people who design the engineering or economic or legal analyses and policy analyses to achieve goals for the city. So it could be equity, sustainability, resilience. And remember that these goals, so technology is a means to an end, and what is the end is what decisions makers set. And these decision makers can be elected democratically or non-democratically in many cases. So again, thinking of this helps you a bit think about technology and how to guide technology to take you where you actually would like to go. So equity is again the theme of this topic. So equity is one of those desired outcomes, right? Sometimes it's very high on the priority, but at least it's a desirable byproduct. It would be hard to find a lot of people, I'm sure you can find some, that would argue that equity is not a desirable outcome and we should work towards inequity, right? At least as a desirable byproduct, equity is always on the wish list of decision makers in cities. Now, this is again why I was basically encouraged to write this kind of short article that appeared in the CITP Lawyer about an equitable technological future for cities. And this is going to be the rest of my talk, focusing on some of the questions and ideas that I basically talk about in this article. So the article starts with basically, again, some questions to frame the thinking about where we would fall on this utopia-dystopia spectrum. So you can think of, artificial intelligence. Would it be able to correct or perpetuate historic discriminatory practices in cities? You can think about urban heat mitigation strategies and new ecosystem amenities. Will they be fairly deployed across all neighborhoods, or will they favor rich neighborhoods? Will new mobility technologies, Uber, Lyft, and so on, I'm going to talk about it in a minute, be accessible to all citizens and localities? Will new policing or security technology deployment have intended or unintended bias? Who will pay to bring infrastructure into the 21st century? Who owns the data collected by the myriad smart devices that we are deploying? And who is trusted to oversee these data? And then who is responsible when technology does not function as intended? So these are kind of the example of the questions we struggle with, or we kind of think about from in this kind of utopia, dystopia framework. But what I try to do is basically, well, I'll talk about it in a minute, ask questions that are a bit more fundamentals about the role of technology. But first, basically, again, on this spectrum, there's a lot of success stories about what urban technology was able to do for cities. So now, you guys are mostly young, but when I used to travel, my first trips, we had no iPhones and no maps. So you had to open a paper map and try to figure what corner you are on and navigate. It was tedious. It was extremely tedious. Now it's much simpler. You open the app and basically it takes you wherever you want. So this is basically made navigating a new city much more easy and much friendlier. It makes cities friendlier. There's other success stories. For example, this is an app that was developed and first deployed at Boston. It's called street pump. So you activate it, and when your car goes over a pothole or a bump, it sends a signal with the location of that pothole to the city, and the city will realize there's a problem here, and they can go and fix it. Other success stories, for example, now we're thinking about a lot of novel materials, for example, self-healing asphalt, that basically will, when there's a crack, it will kind of autofill itself. You think about also a lot of innovative materials in terms of buildings and so on. There's also a lot of efforts now to basically engage citizen science in collecting data about how cities are functioning. So this app, for example, tries to collect data from citizens about where what parts of the city are flooded, and then by integrating a big data set over a long periods of time, they'll have a better information about flood risk and hazards across multiple cities. So these are great examples where technology actually did already have a positive impact on cities. Now, so these are kind of examples of success. So one challenge is, does this scale up? So one telling story is that of Columbus, Ohio, who won a $50 million grant from DOT to basically become the poster city for smart cities, right? The city government obviously was extremely committed to this effort, and they had all the ingredients of success that you think a city will want to have. However, 5 years later, as multiple articles talk about now, the success was limited. It was not zero, but it was quite limited. Scaling up turns out to be difficult. For example, only about 1,000 people downloaded the public transport integration app, which is a single app that allows you to buy tickets across all modes and basically navigate the city. And the self-driving shuttle that was designed turned out to be too slow to cross a main road, so it was not adopted. So again, there was not a lot of discussion maybe between the developers, the users, and integrators of this technology here. So scaling up from individual technology that solve a problem to a smart city that's kind of very utopian and where everything is great is not that easy. The other challenge is that you can think about a lot of counterexamples where technology actually has a negative impact on cities. So hackers, for example, that hacked into the Colonial Pipeline is an example where basically smart infrastructure can be hacked and basically taken out of service more easily maybe than non-smart technology. Again, at the privacy level, there's a lot of concerns about basically not only hacking, but also how companies that you give your data to are using these data. These are, and there's even more striking counterexamples. So Facebook's AI labeled some black men in a video as primates. And it's easy directly to throw, eggs at Zuckerberg. However, Google did the same. So the Google AI technology, unfortunately, also through its facial recognition software, labeled some African American men as gorillas. So this is, you go from maybe something that is a little bit benign to something that can become extremely serious in the first and last two examples. So there are counterexamples where technology malfunctions and can have a significant impact. So beside these beside this technology, the positive and negatives and how you use it, there's also the problem of this utopian vision that technology can solve all the problems that city have, forgetting kind of the initial state we are in. So if you want to think about equity, you really need to keep in mind that it's an initial value problem, and where you are today is a state that's going to be difficult to change very quickly through just silver bullet technologies. So you have basically, these are a map of LA with income, the greener, the darker, the higher the income, and the surface temperature in the city. you clearly see that the low-income neighborhoods have much higher temperatures and the higher income have much lower temperatures. So there's a heat inequity in New York today. And again, you think, okay, how can I redress it? So to redress it, if this is your initial condition, you have to put a lot of effort to kind of removing this inequity from your city. So this is one example that illustrates that today's cities are neither equitable nor sustainable nor resilient. And so this is this reality is a result of past technologies and policy making. And so as you start deploying technology, if you really set your bar very high to think that technology is the silver bullet that will solve all your problem, you'll be setting yourself up for disappointment. Expecting technology or a set of technologies to reverse decades of myopic policy and redlining, to basically peel out and improve layers of suboptimal urban design and infrastructure in the past, or to be quick solutions for very complex problems that require, again, action at the socio-economic level and at many other levels, will set you up for disappointment. So keep your expectations within reality, I would say. So then, if you want to do this, what I tried at this article is to frame what I tried to do is to frame 3 questions that you can ask when you are thinking about deploying a new technology that tell you at least if technology is going to move you in the right direction. So it cannot solve all your problems, but it can be a powerful agent to push you towards equity, sustainability, and resilience. So for equity, the first question is the technology equally accessible and beneficial to all citizens? And if not, what will people who don't have access to this technology do? Will they be significantly disadvantaged? So let me give you a few examples. Again, the cell phone is fantastic, but as a result, there are no more public phones. New York had the largest number, but they just removed their last public payphone. And it's slowly being replaced by these linked NYC, which are posts that give you kind of a hotspot and phone capabilities, but there's still a limited number of those. So now, of course, if you're someone who don't have a cell phone or your cell phone die, you cannot make a phone call. And that's maybe not a big problem in terms of calling. But then what happens when your cell phone becomes the access, the tool through which you access a lot more services, access to public transport, access to shopping, and access to other things? What would happen to people who don't have a cell phone, or to, if your cell phone battery dies or what have you? So again, this is one example. You can think of other examples, many other examples. So basically, in this first question, you have to think about first about access to technology. So, for example, how do you ensure that less tech savvy and less affluent citizens have access to all the new services that now rely on technology to use them? How do you get private companies to deploy these services equitably in all communities? For example, today in New York, if you take a taxi in Manhattan, it cannot deny you, and you tell it, I want to go to the Bronx, the taxi by law cannot deny you the trip. However, Uber and Lyft can basically do that. And there is no law right now, to the best of my knowledge, at least until recently, to prevent them from doing so. Who pays for technology development for the deployment of essential technology in neighborhoods where maybe it will not be basically profitable by itself? And if you want to sustain, let's say, payphones in New York, if you want to sustain low-tech alternatives, either for resilience purposes or for equity purposes, who's going to pay again for these alternatives when basically market-wise they're not profitable? You also need to think not only about equal access, but also equal benefits. So if you have a few technology, who decides which one do you adopt? what are the priorities that serve citizens equally? For example, there's a very nice movie called Urbanized. If you want to see it, it's on Amazon. And it talks about basically developing low-income housing in Argentina. And one of the questions they were struggling with limited budget is, do we put a water heater or a bathtub a bathtub in these houses? And they thought a lot of people actually will go for the water heater, but when they went and talked to the actual low-income people who will occupy these houses, almost zero people or zero families picked to have the water heater, because basically they currently don't have a water heater. They don't have the money to pay for the heating bill, so they all basically decided to have the bathtub. So again, engaging your citizens to know their priorities and not assuming anything. And how do you again decide on fares and how this technology will be paid for? There's an example on this last point, for example, from transportation. So there's already evidence that Uber actually offers better services, and there's more cars in neighborhoods with more white people. And there's even evidence that basically the price you pay if you take a Uber or a Lyft from a poorer neighborhood is actually higher than what you would pay if you are living in a rich neighborhood. So already there's example. I mean, Uber and Lyft did not design their systems to be inequitable, but the outcome was clearly inequitable for reasons we will not delve to a lot here. But again, this gives you an example of how, in terms of access and in terms of benefit, these technologies might lead to inequitable outcomes. So this is question one. Now, question two is, could the technology discriminate in its interaction with humans based on race, color, sex, and gender identity, sexual orientation? Age is going to be important, actually, national origin, religion, and physical or mental disability. So let me give you an example. I'm not sure if you're familiar with the trolley problem, but here's it's an ethical problem. You're the person sitting here, and you have this lever that you can switch back and forth, and you have the trolley coming, and the trolley is supposed to basically hit the 5 people. If you take no action, these 5-6 people will be killed. You can take an action and flipping this lever, and the trolley will be deviated to kill only 1 person. So if you do nothing, 5 people will die, but you're not responsible for that. It's not your action did not contribute for that. If you take an action, 1 person will die. So what would you do? Of course, that's kind of the classic trolley problem, but you think about now a trolley problem that's a little bit different. So let's think that actually this trolley is coming to hit that 1 person. And if you switch the lever, it will hit and kill the 5 people. If you're a human, obviously you would not do that. That becomes an easy choice. However, what if you are an AI, or what if an AI is making this decision and does not recognize that these 5 people are humans? Maybe these are people of color, and they get labeled as primates. So obviously, an AI might make the decision to switch this and kill all these people. Now, there's also other ethical or equity problem involved in that. What if you're not basically sitting and controlling the lever? What if you're the coder or the computer scientist who's generating the AI that is making that decision? So you're 2 steps from that decision, but do you develop an AI that will make such a, again, if it knows that everyone here is a human, do you make a decision, or do you develop the AI to make such decisions, right? So again, these are things that AI alone don't decide. We decide how to develop these AIs and what flexibility we can give them in making such decisions. These are some of the examples about, again, discrimination. You have other sorts of examples. So as a non-native English speaker, I used to really suffer with speech recognition. It's getting much better, as you may know. But again, so speech recognition technology will be discriminating based on national origin. There's a lot of examples of age discrimination, possibly with kind of access and being technology savvy and so on. So the second question was basically, again, related to this discrimination. And the broader problem of discrimination is machine learning, as you know, relies on training for training on existing data set. And if your existing data set are generated based on historic discriminatory practices, or will these be unintentionally embedded in future AI technology? For example, with policing in many cities, they sent more police to basically communities or neighborhoods that have larger fractions of people with color. Of course, the police is there, so it spots more crime, maybe something as simple as basic. Back in the days, not anymore, someone having marijuana or smoking marijuana, so that in the database you get more crime reported in this neighborhood. And then what would you do as a police force is to send even more police to these neighborhoods. So it becomes a positive feedback loop. Now, this is a problem because a lot of the AI data is generated based on these type of databases. But it gets even a bit more tricky, because what if AI basically makes a decision to send more police to that neighborhood? That AI decision itself creates new data that actually reinforces and worsens these biases. So these are the type of questions or problems with discrimination that we face. Again, you can think about AI making decisions about, let's say, hospital access or treatment and discrimination based on age. So who can oversee and correct AI decisions? What role will city, state, and federal legislation play in regulating AI are all questions that basically relate to the potential problem of discrimination. So at least you want to make sure that your technology is not going to discriminate. Now, the third question is whether the deployment of this technology will have designed or inadvertent bias in terms of favoring access for certain group and income levels. So we go back to this example of heat in LA. Again, rich neighborhoods have lower temperature, and there's also a strong anti-correlation between income and urban and air pollution, not only urban heat. And so early on, I thought, okay, this is a problem of density. So clearly, if you look at median household income versus population density, the really high density neighborhoods tend to have a very low median income. And so you see kind of an upper envelope where basically the higher the density, the more predictable the fact that this neighborhood is going to be a middle or low income becomes. So this is partially related to density. However, if you basically take this a slice of the data, so if you control for density by saying, I'm only going to look at low population density neighborhoods, you would hope, or you expect that maybe some of this anti-correlation or this bias would go away. Actually, it doesn't. So this is work that was done by a summer trainee in my lab, Paul Villamil. So we said, okay, let's take particulate matter data in LA, and let's look only at low density neighborhoods. And this anti-correlation, the fact that if you have a higher income, you're more likely to be in a neighborhood that has a low particulate matter concentration, persists. Again, despite to some extent controlling for density. And so there's a little bit more to the story. There's the problem of, again, the legacy. So historically, for example, in New York and many other cities, the highways that go in and out of the cities were basically built through poorer neighborhoods. And there's a lot of evidence, basically, that if you live in a poor neighborhood, you're exposed to more pollution and so on. And the counter argument is, no, well, that's not actually how it happens. When they build a highway, the prices drop, and so low-income people move into these neighborhoods. But the outcome is the same. It doesn't really matter what's the road you took. The final outcome is the following. There's another outcome that's actually quite interesting that I learned about recently, is that even in low-density neighborhoods, if you are in a rich neighborhood, you'll have the money to have a lush backyard to water that backyard, then you'll have a landscaper. In a lot of poor neighborhoods in LA, basically the backyard is just sand. They don't have, again, the money to maintain vegetation in the backyard. And so as a result, the poor neighborhoods, even when they had the space, they had less vegetation, and so they were exposed to more heat. So again, these are example in terms of how technologies, let's say in this case, green infrastructure technology to cool the city, or in the future electric cars to reduce the particulate matter, could have an impact on equity. So this is the initial condition. And so if you want to go to LA and fix this problem and say, okay, I want to build, plant more trees or change, shift my fleet to electric vehicles, the things to keep in mind is that a fair or equitable outcome cannot result from spatially homogeneous or equal deployment, given the inequitable starting point. So you cannot plant a tree in a poor neighborhood and a tree in a rich neighborhood. You have to basically put a lot more effort into the poorer neighborhoods. So cities in general should examine the broad efforts to upgrade their system and choose new technology, looking at the whole smart portfolio to examine if it addresses the need of all constituents, if it favors politically powerful group who basically know the mayor or the decision maker, and at least if it begins to redress current inequities. It can't suddenly in one day reverse them, but it should move us in the right direction. So technology should at a minimum contribute towards equity rather than vice versa, and vice versa is a possible outcome. But how do you measure this? How do you measure progress? So you're a city maker, you decide that you did design a portfolio of technologies that will make your cities more equitable in one way or another. How do you measure progress? So often as scientists, we're kind of, if you want, tied down by our obsession with accuracy, right? If I tell you I have an inaccurate model of something, you'll all think I'm crazy. Why am I even telling you about that, why am I so happy I have an inaccurate model for something? This goes back to basically the obsession with exactitude in science. And this is a nice story from Jorge Luis Borges, who is basically talking about cartographers in the city. And so there was a kingdom with cartographers that were always unhappy with any map they produced of the city. Eventually, they produced the perfect map that they all were happy with and decided this is the exact map. We don't need to develop anything better, but the map was as big as the city itself. So it was a one-to-one replica. Obviously, such a map is great, but it's useless from a practical perspective. And there's a lot of problems we face when we try to think about problems that are that have a social component in nature, like equity. It's not like measuring temperature, right? So one way, so the measures need to be quantitative, but they can be approximate indicators that you track in time to see whether you're moving in the right or wrong direction when you want to measure equity. So measuring equity could be, some measures, for example, could be the distance of different of citizens to the closest park or to the closest metro station and the variance of this distance in the city or something like that. So you develop these metrics and you track it as you start deploying technology. And when you think about measuring equity, there's a lot of research on this topic, and there's basically some aspects or component or basically facets of equity you can think about. So first, you want to measure or understand your historic legacy, again, your initial condition. How inequitable is your city today? Then you can basically think about profiling the underserved populations or group or individuals that may be underserved or by urban services today. And sometimes, again, these could be broad population, let's say like Latinos or African American, but sometimes they can be subgroups like African American women, for example. And sometimes they can be individuals who are part of multiple groups that together put them at a significant disadvantage. So you want to understand again who today is underserved or who today has an inequitable existence in the city. Then you want to basically understand perceptions, because sometimes people might have their perception of equity and access to urban services might be either better or worse than reality. But you cannot deal with you can deal with perceptions, but not in the same way you deal with reality. So if it's reality, you build another part. If it's perception, you basically try to tell them, well, there is a part next to you that you can use. So the solutions will differ. But perceptions are again important to have an engaged citizens, right? And there's again other components. So measuring the input, so how much effort and funds you are dedicating to reducing inequity, and then not only the input but how effective they are. So if you put some money into a program to plant more trees or to have more stations like Link NYC, you shouldn't only measure the inputs but also the output in terms of, for example, how many trees or Link NYC you have deployed per unit area in your low-income neighborhoods. But outputs again are not sufficient. You need to think about outcomes. So when you put more trees or hotspots, was that something that your let's say minority population or low-income population, is that something that they actually needed? Again, going back to the examples in Argentina, or if you want a bathtub or a hot water heater. So this is why it's important to kind of co-produce these plans with your citizens to ensure that when you put a lot of input or effort, you're actually producing outputs and outcomes, not only outputs. And this is a nice actually report on measuring equity from an energy efficiency program, if you're interested more in these questions of measurements. So the final thoughts again is when you want to deploy technology, it's very important to not assume what the population wants. So for example, this Mexican city, the mayor and some tech companies decided they want to make it again a poster child for smart technology. But once they started actually trying to do anything, there was a lot of opposition, and the plans were turned, were stopped. Google in Toronto is another example of, again, efforts to deploy smart technology that are then stopped by citizens. So engaging citizens and stakeholders to co-produce technology plans very early on is the slow way to do it, but it's the one that most likely will lead to success. You want to, again, engage citizens who are going to be affected in their everyday life by this technological change, and assuring them, for example, that the investments are not diverting funds from school or other essential services. So the problem with this is that if kind of engaged citizenship and good governance are what is needed for success, cities that already have transparent and trusted governance may have an easier task in embracing technological solutions with their citizens and ensuring equitable outcome compared to efforts that are being tried by in less democratic cities or tech companies, which basically means that it might be that the cities that are most equitable and livable to start with will benefit the most from technology in terms of further enhancing equity and livability, which basically tells you that even if your interurban equity, so within a city, may increase, the inequity between cities, so the interurban equity may decrease, especially at the planetary scale. And when we think about cities, it's easy to think about the ones close to us, but we're live on a single planet, and basically, if all these cities that will be the biggest in the world in 2100 are inequitable and suffer from the consequences of climate change, or don't adopt sustainable ways of producing energy, the impact will be planetary, not only in these cities. This is the biggest 20 cities in the world by population, and as you already saw, by 2100, all these 20 big cities will be in Africa and will be in sub-Saharan, well, in Africa and South Asia. So keep that in mind when thinking about equity. It's not only a problem in American cities, it's a planetary problem. So that was my last slide. So thanks a lot.